Imagine falling from the sky at nearly 300 kilometers per hour. Now imagine the only thing standing between a safe landing and disaster is a pair of metal legs beneath the aircraft. Every time a passenger plane touches down, its landing gear absorbs forces that can exceed 200 tons in just a few seconds. But here's what nobody tells you. The most trusted part of an A-plane begins its journey deep beneath the Earth's surface. Today, we're going inside one of the world's most advanced factories to discover how engineers create a machine that pilots trust with millions of lives every single day. Think about this. A modern passenger aircraft may fly for more than 30 years and complete over 100,000 takeoffs and landings. During every landing, the gear must perform perfectly without hesitation. It faces freezing temperatures above the clouds, scorching heat on desert runways, heavy rain, snow, and violent crosswinds. One tiny hidden defect could change everything, which is why manufacturing this system demands absolute perfection from the very first piece of metal. Most people imagine landing gear starts inside a factory. The truth is, its story begins thousands of kilometers away inside iron ore mines in Australia and Brazil, while critical alloying metals come from Canada, South Africa, and Kazakhstan. Massive haul trucks carry hundreds of tons of ore at a time before trains and cargo ships transport these raw materials across oceans. Some pieces travel more than 15,000 kilometers before reaching the forging plant. The steel inside landing gear is unlike ordinary construction steel. Engineers use ultra-high-strength alloys such as 300M steel, containing carefully controlled amounts of chromium, nickel, molybdenum, vanadium, and silicon. Purity levels often exceed 99.9%, because even microscopic impurities can create weak points under repeated stress. What happens next surprised even experienced engineers. The metal is inspected long before it ever enters a furnace. Every alloy arrives as enormous forged billets weighing anywhere from 500 kilograms to more than 5 tons. Before production begins, technicians use ultrasonic scanners to search deep inside each block for invisible cracks or trapped air pockets. The machines send high-frequency sound waves through solid steel, revealing flaws smaller than a grain of rice. If even one hidden defect appears, the entire billet gets rejected without hesitation. Producing aerospace-grade steel also comes with a significant environmental cost. Steelmaking requires enormous amounts of electricity and heat, while mining operations consume vast quantities of fuel and water. Manufacturers now recycle high-value aerospace scrap and increasingly power electric arc furnaces with renewable energy to reduce emissions. But the real transformation begins when these flawless steel blocks enter a furnace hotter than flowing lava, and that's where our factory journey becomes truly extraordinary. The moment has finally arrived. The flawless steel billet enters a gas-fired forging furnace where temperatures climb to 1,100 to 1,200 degrees Celsius, 2,012 to 2,192 degrees Fahrenheit. Inside the furnace, the air shimmers with intense heat, and the steel slowly glows from dark red to brilliant orange. You can hear the roar of powerful burners as the solid metal softens just enough to be shaped, but it never melts. Every second counts, because the forging team has only a short window before the metal begins to cool. Within minutes, robotic manipulators grip the glowing billet and carry it to a hydraulic forging press capable of producing 30,000 to 50,000 tons of force. As the giant press closes, the entire building seems to shake. Each thunderous strike compresses the metal, forcing its internal grain structure to flow along the shape of the landing gear. This hidden alignment dramatically increases strength and fatigue resistance, creating a component that can survive decades of brutal landings. But one press isn't enough. The partially formed component returns to the furnace several times before entering different forging dies that gradually create a complex shape. Workers constantly monitor the surface temperature using infrared sensors, ensuring it never drops below the required forging range. If the metal cools too much, microscopic cracks can form without anyone seeing them. Most people never think about how much precision hides inside something that looks so incredibly powerful. Once forging is complete, the red-hot part cools under carefully controlled conditions to prevent internal stress. After cooling, technicians remove excess material using powerful bandsaws and abrasive cutting machines. The factory fills with a sharp scent of hot metal while showers of bright sparks illuminate the workshop. Even though the part now resembles landing gear, nearly 40% of its original material will still be removed during machining. Now, the forge blank enters one of the factory's most advanced 5-axis CNC machining centers. Diamond-coated cutting tools spin at speeds between 3,000 and 8,000 revolutions per minute, shaving away tiny layers of hardened steel with incredible accuracy. High-pressure coolant sprays over the cutting area at nearly 70 bar, keeping both the tool and the metal cool while carrying away glowing metal chips. Every movement is measured in fractions of a millimeter. Hour after hour, the machine sculpts complex mounting points, axle supports, hydraulic passages, and attachment holes. Laser measurement systems continuously verify each dimension before the next tool begins cutting. The finished surface looks almost like polished silver, reflecting every light inside the factory. And just when you think the hardest work is over, the landing gear faces the most demanding treatment of its entire life, a process that changes the metal itself from the inside out. The freshly machined landing gear may look complete, but inside, the steel still lacks the strength needed to survive thousands of landings. This is where it enters one of the most carefully controlled stages of production, heat treatment. Massive compute-controlled furnaces raise the temperature to approximately 870 degrees Celsius, 1,598 degrees Fahrenheit for several hours, allowing the steel's internal crystal structure to transform. What happens next is so dramatic that even experienced engineers stop to watch. As soon as the heating cycle ends, robotic cranes lift the glowing component and lower it into a giant tank of specially formulated quenching oil. The temperature drops within seconds, creating clouds of thick smoke and an explosive hiss that echoes across the factory. This rapid cooling locks an incredibly hard structure inside the steel. Without this process, the landing gear could never withstand the repeated shock of heavy aircraft landings. But steel this hard can become brittle, so engineers immediately perform a second process called tempering. The component returns to another furnace at around 300 to 600 degrees Celsius, 572 to 1,112 degrees Fahrenheit, for several hours. This carefully balances hardness with toughness, allowing the landing gear to flex slightly under enormous loads instead of cracking. Most people never realize that strength alone isn't enough. Control flexibility saves lives. The heat-treated component now moves into surface finishing. Automated grinding machines remove microscopic imperfections, while precision polishing wheels create an exceptionally smooth finish. Workers carefully inspect every curve under powerful white inspection lights, because even a tiny surface scratch could become the starting point for a fatigue crack years later. The polished steel shines almost like a mirror. Next comes corrosion protection. Depending on the aircraft design, engineers apply advanced coatings such as hard chrome replacement, high-velocity thermal spray, or specialized aerospace paint systems only a few microns thick. These protective layers defend the landing gear against moisture, hydraulic fluid, salt, ice, and extreme temperature changes during decades of service. Every coating must bond perfectly with the steel beneath it. Finally, assembly begins. Skilled technicians install precision bearings, titanium fasteners, hydraulic actuators, shock absorbers filled with nitrogen and hydraulic oil, wheel axles, brake mounting points, and dozens of high-strength components. Every bolt is tightened using digital torque tools calibrated to exact specifications, while each hydraulic connection undergoes leak testing before approval. The landing gear now looks ready for flight, but one final challenge still remains. Before it ever carries a single passenger, engineers will push it far beyond anything nature could ever throw at it. Now comes a stage where there are no second chances. Before a single landing gear can leave the factory, it must prove that every hidden detail meets aerospace standards. Imagine spending months building a component, only to reject it because of a flaw smaller than a human hair. In this factory, safety always wins over speed. The inspection begins with powerful coordinate measuring machines, or CMMs. Their precision probes glide across the landing gear, recording thousands of measurements with an accuracy better than plus or minus 0.01 millimeters. Every hole, curve, and mounting surface must match the digital design perfectly. If even one measurement falls outside tolerance, the entire component returns a correction or is rejected completely. Next, engineers search for invisible defects using ultrasonic testing, magnetic particle inspection, and fluorescent penetrant testing. Under ultraviolet light, tiny cracks glow bright green, revealing imperfections invisible to the naked eye. Even a crack measuring only a few microns can disqualify a part designed to protect hundreds of lives. What happens next surprised even experienced engineers. The finished assembly now faces one of the toughest tests in aviation. Giant hydraulic rigs apply loads exceeding 1.5 times the maximum force expected during real landings, generating pressures of more than 350 bar, 5,000 psi. The massive steel structure bends ever so slightly before returning to its original shape. Sensors record every movement thousands of times each second, ensuring nothing escapes detection. But strength alone isn't enough. Engineers perform fatigue testing, repeatedly compressing and extending the landing gear for hundreds of thousands of cycles, simulating decades of airline service. The rhythmic sound of hydraulic actuators echoes day and night as computers monitor every fraction of movement. Only the strongest designs survive this relentless punishment. Despite all this automation, one final inspection still depends on human expertise. Veteran aerospace inspectors run their hands across polished surfaces, checking areas where years of experience can detect subtle imperfections that machines sometimes overlook. In factories like this, robots deliver unmatched precision, but skilled human judgment still makes a final decision. Only after passing every inspection does a landing gear receive its certification under international aerospace standards such as AS9100 and move toward the aircraft assembly line. You might think the journey is over, but it's only beginning. These incredible machines will soon travel across continents before supporting aircraft carrying millions of passengers every year. And the numbers behind this global industry are almost impossible to believe. In the next chapter, we'll uncover the factories, countries, and astonishing statistics that keep the world's aviation industry safely in the air. Now let's zoom out and see the incredible scale behind this industry. Every year, aerospace manufacturers produce tens of thousands of landing gear systems for commercial airliners, military aircraft, business jets, helicopters, and cargo planes. The global aircraft landing gear market is valued at more than $15 billion, and experts expect it to continue growing as air travel expands worldwide. Think about this. Every new aircraft that rolls out of a factory depends on one of these engineering masterpieces before it can ever leave the ground. The world's leading landing gear manufacturers supply aircraft builders across every continent. Countries including the United States, France, Germany, Canada, and the United Kingdom lead the industry through decades of engineering innovation and precision manufacturing. Together, hundreds of specialized suppliers produce thousands of individual parts that must fit together with near-perfect accuracy. One missing component can delay the delivery of an entire aircraft. Here's a surprising fact. Some modern landing gear assemblies weigh more than 4 tons, yet they extend and retract with incredible precision in just a matter of seconds. Another amazing fact is that every major landing gear design must survive testing far beyond the loads it will ever experience during normal airline service. And perhaps the most astonishing fact of all, many landing gear systems remain safely in service a decade through scheduled inspections, maintenance, and complete overhauls. Over the last 50 years, aircraft landing gear has evolved from heavy mechanical systems into highly engineered masterpieces built with advanced alloys, titanium, composite materials, digital sensors, and intelligent monitoring systems. Looking ahead, engineers are developing lighter structures, smarter health monitoring technology, and environmentally friendly manufacturing methods that will make future aircraft even safer and more efficient. The next generation of aviation is already taking shape inside factories like the one you've seen today. From iron ore buried beneath the Earth's surface to one of the most safety-critical components ever engineered, every step in this journey demands precision, patience, and extraordinary skill. Every furnace, every robotic machine, every engineer, and every inspection exists for one simple reason: to ensure that millions of passengers arrive home safely after every flight. The next time you watch an airplane touch down, you'll know that those few seconds represent years of research, thousands of hours of manufacturing, and countless quality checks hidden beneath the aircraft. What looks like 2 simple wheels supporting an airplane is actually one of the greatest engineering achievements of the modern world. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.